Hello, hi, good morning my dear students, welcome to the chemistry class. In the last week we have begun a new chapter, that is states of matter. Here the states of matter is going to discuss only on the basis of gaseous compound and liquid compounds. Why? Because in the solid we are going to study in detail in second QC. So that we have begun a gaseous. In gaseous there are some laws. So based on those laws, based on those terms, we have discussed the Pv is equal to nRT, that is about the ideal gas expression. In this ideal gas expression, we are continuing the some terms, means we are going to derive some of the equations. So according to the Pv is equal to nRT, so whereas this Pv is equal to nRT, we are going to call this as the equation of ideal gas expression. Ideal gas equation. Here P pressure, V volume, R is the gas constant, N is number of moles, T is the temperature. I hope you remember this one. If not, please do remember this one. This is a very important and it will be going to use in next coming class even for the higher education. So let's start. Today we are having the new concept in this states of matter, that is Dalton's law of partial pressure. So it is important for your examination point. It will be asked for at least 1 or 2 months, properly 2 months. So how means state the Dalton's law of partial pressure. This is the statement. You have to say the law. So here this law is going to state that what that Dalton's, the name of the scientist, is going to say that the partial pressure of different gases, means we are having the mixture. Each of the individual gases are having the pressure. In that there are some individual mixture of the gases. Here those gaseous mixture are not going to react with each other. Therefore the mixture of non-reactive gaseous molecules, means the total pressure of the mixture of non-reactive gaseous molecules is equal to the sum of individual partial pressure of the gas. Means the pressure of total gas. In that we are having the, in container we are having different gases, A, B, C, D, like that. These gases do not react with each other. Therefore these are the non-reactive gases. The partial pressure of A gas is Pa, the partial pressure of B is Pb, this is Pc, this is Pd. Means the total pressure exerted by the mixture of this A, B, C, D gases is equal to, the total pressure is equal to the pressure of individual gases, means Pa plus Pb plus Pc plus Pd. Whereas these gases are not going to react with each other. It means that these are non-reactive gaseous compound for themselves only, but they are mixed, they are placed in one container. Therefore the total pressure is equal to, is a mixture of non-reactive gaseous compounds. State that Dalton's law of partial pressure, means it states that the mixture of non-reactive gaseous compound, the total pressure is equal to the sum of individual gaseous pressure. This is called as Dalton's law of partial pressure. So here P total is equal to P1 plus P2 plus P3. If it is 3, up to 5 is 5. So that's why I have written it is continuation. So this is condition arises at constant temperature and volume. At constant temperature and volume, the Dalton's partial pressure says that the mixture of non-reactive gases are the sum of individual gases of those pressures. So we know that Pv is equal to nRT. I have written here. Why I am continuing here? So when the pressure I have taken as P1, at this condition, number of moles are going to vary. Why? Because temperature and volumes are kept constant. So if the temperature and volumes are constant, it means that the variation is along with the pressure. Number of moles has to be vary. Why? Because R is also constant. Volume and temperature are already constant. For that reason, as pressure changes, number of molecules are also going to change. So here, according to the P, if I need P value, means P is equal to nRT divided by V. I am rearranging this equation. I am sending V to the right side. Therefore, into V becomes divided by V. Therefore, if P1 is equal to N1 RT by V, RT, V are the constant. If P2 is equal to N2 RT by V. Are you getting how I am writing this one? So based on this equation, PV is equal to nRT. I change the equation. Once I rearrange to get the pressure equation. So if P1 N is converted as N1, at P2 N is becomes N2. Remaining the gas constant, temperature, volume, these are the constant. It means that I have written P1, P2 like that, P3, P4, it can be continued. So why I have written these? Just to substitute those values here. So total partial pressure is equal to P1 is the P1 part, N1 RTV, RT divided by V. Similarly N2 RTV. So here can you see here RT divided by V is the common. Therefore I would like to take the common as a RT divided by V. Then remaining is N1 plus N2. If it is there some terms, it will be continued. N1 plus N2 up to dash dash. So it means that total pressure is equal to N1 plus N2 plus, it will be continuous by the constant RT divided by V. Isn't it? So here, if I would like to calculate the by dividing P1 by total pressures, P1 divided by P total. So P1 is nothing but what? We are having the value N1 divided N1 into RT by V. N1 into RT by V. If the same thing, if I begins to divide the by PT, total partial pressure, that is, it becomes N1 plus N2 plus N3. Therefore, first I will write V here. N1 plus N2 plus so on into what happens here? RT divided by V. RT, I would like to write RT here. RT and RT divided by V. This V I have written here. P1. Can you say RT divided by RT divided by V and PT? It's RT I have written here. V, if it is divided by V, this V will move to the upper side. It will move to the upper side. How? Because AB whole divided by PQ. We can write this AB whole divided by PQ. Can you see here? Here I have written P1 divided by PT. P1 divided by PT. P1 is nothing but what here? So P1 is nothing but N1 RT divided by V. N1 RT divided by V. I have written here N1 RT divided by V. This is P1. About PT is nothing but R N1 plus N2 up to so on into RT divided by V. I have written RT here whole divided by V, that is going to form as a numerical value. How? Because A divided by B whole divided by 3 upon Q. It can be written as A upon B and this divide becomes into P by Q. Q will move to the numerator. Q divided by P. For that reason, according to this expression, RT by V I have written for the P1 RT by V. So here PT RT, this is about the PT equation. So total partial pressure in this expression RT I have written here. The volume of this total pressure I have written in the numerator. Why? Because if the in the denominator whole divided by, if it is coming again denominator, we can convert that into the numerator. I hope you can be able to understand this expression, because in the previous also it came actually this conversion method. P1 divided by P total, that can be written as N1 RTV whole divided by N1 plus N2 plus so on into RT. Why I am writing this one means, why? Because here by calculating this one, just look here in the numerator and denominator, we are having RTV. So we will divide this RTV and remaining is P1 divided by PT is equal to N1 divided by N1 plus N2, N1 plus N2 plus so on. So it means that it is total number of particles, number of moles, N1 plus N2 plus up to so on, means it is total N. Total N. The remaining everything is RTV divided by RTV. These are mutually cancelled each other. Therefore, we know that n1 by n is nothing but x1. So x is nothing but mole fraction. So mole fraction we can calculate the number of mole fraction of component A. In the first chapter we have discussed the number of moles of component A is nothing but mole fraction of XA NA divided by NK plus NB. I hope you remember this one. We discussed about this in first chapter. So mole fraction of component A is equal to number of moles of component A whole divided by the sum of number of moles of all the components. Similarly here N1 divided by N1 divided by N means total N. So we are calculating the number of moles of 1 with respect to 1. Therefore X1 is nothing but mole fraction of first component. Therefore N1 by N, here it is N1 whole divided by N1 plus N2 plus N3 something, that is total N it is. So total N can be written as simply N. Therefore N1 by N is nothing but mole fraction of component 1. Therefore, so it means that P1 divided by Pt is equal to X1. P1 divided by Pt is equal to X1. Therefore we can write P1 is equal to P total into X1. P1 is equal to P total into X1. Or if you want to write the P2 means we can write Pt as it is Pt into X2. So here P1 is nothing but what? P1 is the individual partial pressure of component A, whereas P1 is equal to Pt means total partial pressure of the component. X1 is nothing but mole fraction of component means gaseous component 1. Similarly, if we change it for the partial pressure of 2, P2 is nothing but Pt means total partial pressure into X2. X2 is nothing but mole fraction of component 2. So here what I did is I have given you the expression P1 is equal to what? Whenever you can write P1 is equal to P total into X1. This is the formula you have to remember. So this is how we have generated from the Dalton's law of partial pressure. This is the only statement. This is the expression Pt is equal to P1 plus P2 plus P3 up to so on at constant temperature and volume. This is called as Dalton's partial pressure. Whereas here by this expression we have generated a formula that is P1 is equal to Pt into X1. So you have to remember P1 is nothing but partial pressure of the first gaseous component 1, whereas P total is the total partial pressure. X1 is nothing but mole fraction. Mole fraction can be calculated as N1 upon N. N1 is nothing but number of moles of component first one divided by N is nothing but total number of moles of the remaining component. So here we have written that P1 formula we have generated Pb is equal to nRT. So if P is equal to nRT by rearranging this one, P1 is equal to at P1 N becomes N1, remaining RTB is the constant. Similarly P2 is equal to N2 RT divided by V. So we are substituting the value of P1, P2, P3 and we have rearranged the equation and we have taken the RT divided by V as a common. Therefore remaining is N1 plus N2 plus N3 and so on. Therefore now we did a new thing. So this is first one, this is second and this is the third expression. So while writing, just please do follow, don't write randomly. This is about the expression. Soon after this one we have to begin from here and after that one we have to start from this expression. So actually they are not asking you to derive, but Dalton's partial pressure statement and this expression, only this expression of this is important. So here we are dividing P1 divided by Pt and soon by dividing this all component we are going to get the value P1 upon Pt is equal to X1. That is rearranging P1 is equal to P2, P1 is equal to Pt into X1 we are getting. So here I am going to tell you the clear thing is the Dalton's partial pressure of the gaseous compound. These are going to explain you that the individual gaseous pressure together it is, these are non-reactive individual gases pressure, together it is going to form as a sum of partial pressure. This is called as Dalton's law of partial pressure and by this expression we have derived the formula P1 is equal to Pt into X1. you have to remember this expression. P1 matlab partial pressure of first gaseous. Pt is nothing but total partial pressure. X1 is nothing but mole fraction of first component. Are you getting? If you want to write the P2 means same thing, P2 is equal to, you have to write the Pt as it is, X1 as X2. So this is about the Dalton's law of partial pressure. So see here, so next one is the kinetic molecular theory. So here the kinetic molecular theory of gases. So gaseous compound, they are undergo the kinetic energy. So in the energy there are two types of the energy. One is potential energy, another one is kinetic energy. You are going to study about these energies in physics. So in physics you have already studied it. Kannada medium student, you know chalana shakti ಮತ್ತು ಪ್ರಚನ್ನ ಶಕ್ತಿ. So here chalana shakti andre particles ಈಗ ನಡೀತಾ ಇದ್ದೀನಿ ಅಂತ, this means I am expressing the kinetic energy. Kinetic energy is nothing but when I am moving from one position to one place to the another place, at this condition my body is expressing the kinetic energy. If I am staying here and talking means I am expressing the potential energy. Potential energy is nothing but what? ಒಂದೇ ಕಡೆ ಎನರ್ಜಿ ಇದ್ದಾಗ, ಒಂದೇ ಕಡೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದ್ದಾಗ ಏನು ಎನರ್ಜಿ ಜನರೇಟ್ ಆಗುತ್ತಲ್ಲ ಅದನ್ನು ಪ್ರಚನ್ನ ಶಕ್ತಿ ಅಂತ ಕರಿತೀವಿ ಕನ್ನಡದಲ್ಲಿ. ಸೊ ಹಿಯರ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸೇ ದಟ್ ಆಸ್ ಅ potential energy, but I am not talking about the potential energy, I am talking about the kinetic energy. So a kinetic, whenever we use the word kinetic, you have to remember that the particles are moving. Any of the body, it is undergo motion. So movement ಆದರಷ್ಟೇ ಏನಾಗುತ್ತೆ, that is expressing the energy, that is kinetic energy. Are you clear about this one? So here the theory is the gaseous compounds are undergo the kinetic molecular theory. So here the gaseous compound are exhibiting the kinetic energy. Why? Because in the three states, in the states of matter, solid, liquid and gaseous, the solids do not undergo any motion, and liquid they are slightly undergo the motion, and the gaseous compound, the third one, it is having free molecules. They are never going to occupy a fixed position. It means that they are going to occupy all the container, means they are going to move in a random. For that reason all the gaseous compounds are undergo movement, they undergo motion. For that reason the kinetic molecular theory of gases is going to express how these gases are undergo the kinetic energy. So this is very much important for your examination point. Explain the kinetic molecular theory of gases. They may ask you such questions for 3 marks. Otherwise they also give you this kinetic molecular theory gas. This is also called as assumption of gases. Assumptions of gases are postulates. Write the postulates of kinetic molecular theory, or write the assumptions of kinetic molecular theory. Everything is same. Assumptions are nothing but postulates. Both are same. Assumption ಅಂತಂದ್ರೆ ಕಲ್ಪನೆ ಮಾಡ್ಕೊಂಡು ಹೇಳೋರು, postulates ಅಂದ್ರೆ ಸಿದ್ಧಾಂತ. postulates ನಾವು ಸಿದ್ಧಾಂತ ಅಂತ ಕರಿತೀವಿ. So kinetic molecular theory of gases. So let's begin. Here I have noticed a short note on kinetic molecular theory. If you want, you can write the same thing, but you should remember that grammatical I have not completed the sentence. For my convenience, to make you to be a clear point by text, for that reason I have written here. So along with that I will spell you some of the words. So if it is comfortable means you can go through this one, otherwise I will send you the notes of this. Okay, so coming to the first one, look here, these points are very much important, and don't behind this one. Why? Because if you understand the answers means it will be easy. First one, the gaseous compounds are large number of identical particles. Identical particles. Here the gaseous compounds are, if I am staying in the classroom means I am not observing the different gases here. It means that if the gases are very much different means I can have a smell of different gases. In other words, if one of the container is having the gases, the number of gas will not a little, the large number of gases will be there, and those gases are identical particles. They are seems to be the same. That's why I am not differentiating those compounds. For that reason, if I am having different gaseous compounds, I can have a smell. If you move away from the Hubli at the road of Karwar, you can feel a different smell. Why? Because these are some gases are generating there. That's why you are feeling that is a bad smell, good smell. It means that the gases are different. So here, so commonly I am saying that in around the gases which are in the large number of identical particles. So number of particles are large and they are having the identical means same. They are having the same. Hydrogen means only hydrogen compounds. Large number of hydrogen. Nitrogen means large number of nitrogen. Carbon dioxide means large number of carbon dioxide. So these are the large number of identical particles and they are in the size very small. They are having the very small size and we are going to actual volume we are neglecting, means we are going to neglect the actual volume. So think that it is a container we are having. In this container I have dropped some of the gases. If actually what is the volume of the container, it is not possible to say. Why? Because the gaseous molecules are undergo in everywhere. So what is the real and actual volume of the gas? It is not possible to identify. Why? Because the particles are very small. We can't able to even see by our normal eyes. So to that extent they are small and number of particles are very large and they are similar, identical. So it means the gaseous compound, all the gases are in a large number of identical particles and they are very small in the size. For that reason we are going to neglect the actual volume of the gas. We are going to neglect the actual volume of the gas. For that reason we said that the gases do not have a fixed volume. The gas do not have the fixed volume, even they do not have the fixed shape also. This is about the first term. Second term is there is no force of attraction between the force of attraction. There is no force of attraction between the gases at ordinary temperature and pressure. Ordinary temperature and pressure. So it means that the gaseous molecules do not have the attraction between them. So think that there are 2 or 3 gases, different gases. These gases are not having the attraction. One gas is not attracting the other one because gaseous compound are the neutral gases. So these gases are almost all the gases. They are not having the force of attraction between the gases at ordinary temperature and pressure. Means the temperature should be ordinary, means a normal 25 degrees Celsius and pressure is around 1 bar or like that. So we should not have the changes. If the temperature changes means compulsorily the gas are not attracting, but there will be some movement will generate. So it means that at the normal temperature and pressure, gases do not have any force of attraction between them. So it means that the gases are not having any force of attraction between them at ordinary temperature and pressure. If we can, by applying the pressure, we can say that the particles are coming outside. By hitting that one, we can say that the gases are expanding. It means that by our external force, they are undergo the compression and moving apart from, but not they are actually having any attraction in the gases. So this is about the second term or second assumptions you can say. The third one is the gaseous particles are always a constant and random motion. Always a constant and random motion. So it means that think that I can't say the gases are here, they are stored here, they are placed here, they are occupy their position. Means they are not in a constant, they are not going to be settled in one position. They are always undergo the movement. A random movement will be present. Why? Because the gaseous compound being a very small and very lighter in a weight, they are undergo the movement. The movement of the particles will be the fast and it will move anywhere and they never going to be settled in one position. For that reason, we are going to say that always at constant. Constant means they are not going to change their speed. That speed means movement of the gaseous particles remain same only. Why it changes means only when the external. If I simply bring my hand to the very faster side. If I say like this means the gaseous particles will move in a faster way. If I kept constantly means the gases will be move in a constant speed. Are you understanding? So it means that the gaseous molecules in a surrounding they are always constantly undergo the random motion. Constantly undergo the random motion. Random is nothing but the gases do not have any charges. It means that they are not having any particular path. They are not going to the north, they are never going to the up, they are never moving to the down, not going to the east, west. There is no conditions. But they will move in a random. However they want, however they apply the force, on that basis the gases are moving. This is the third one. Next, fourth one is the gaseous particles move in all the possible direction. All the possible direction in a straight line. In a straight line. Straight line is nothing but what just now I said. if I'm moving towards this mobile camera, so if moving means the in between this mobile and me, there are some gases. If I come in here near means the gaseous compounds which are present in between this, I pushed them by my body. So it means that they moved in a different direction, but in a straight line. So think that if the gaseous molecules are moving in a randomly, if gases is moving here, there are number of gases. If one gas is moving here, think that here, if one gas is moving here and it will touch to the one particle and it will begins to move in another direction, means the direction of the gases will changes. So at the time when it is moving, it will always move in a straight line. So it will move in a straight line after bombarding, means colliding, touching to the one particles, and again it will change its direction, but it will move in a straight direction. So when another particles will touch, and this also under the direction different, and this will also under the different direction. Means if the particles touch to the another one, and it will change the direction, and it will move in a straight line. Again it will change its motion by bombarding with the other compound. If it touches, again it will go different direction. Means when the particles are moving in a under motion, if they collide with each other, means they are bombarded or touched with some surface, they are always moving in a positive direction. If it like moving in this path, if it touches means again it undergo the direction of this path is changing. If it is moved here, means it will not move in another random motion, but it will move in a straight way. If it is touched here, means it will come here. Similarly, if it is touched here, means it will move here. So it means that the movement of the particle is always in a straight line. They will move at any direction. It can move up, it can move down, it can move in any angle, but always it will move in a straight line only. It will always move. So particles move in a possible direction, but compulsorily in a straight line. This is the fourth point. So next one is the gaseous molecules are perfect elastic. These are perfectly elastic. What is this perfect elastic? Perfect elastic means, I hope you remember the elastic when I apply the force of this rubber, the rubber bond means that elastic is expanding. So when I relieve that rubber means it's going to be come to the original position. So it means that by applying the energy is expanding. Soon after leaving that one, it's coming to the original position. So this elastic. So what is this perfect elastic? It means that before and after the collision. Collision is nothing but bombarding. So if one particles come here and another particle will come here, if it collide each other, if it touch each other, if it bombard each other, bombard is nothing but touching. Collide is nothing but touching. If it collide each other, they are before collision and after collision. Means before dashing to the another compound, before dashing and after dashing to the two molecules. Before and after the collision of gases, the total energy remains same. So it means that the gaseous molecules are going to collide. Collision is nothing but collide. They are going to collide. The number of total energy before the collision and after the collision, they remain same. Means here the gases on the collision before and after, the total energy remains same. Means the gaseous compound before the collision and after the collision, the total energy of gases remains same. This is called as perfect elastic. Here I am saying that think that the gases are moving in different way. If they touched each other, so before touching each other, how much they are having energy, that energy remains same. After touching, this will move here and it will move here, and they are changing their direction. If it comes here means it will move again here. So before touching each other, means before collision, they are having some energy. After touching, they are having different energy, but together the total energy will remain same. I would like to give you one example for you people. Think that I am having two particles, gaseous particles. One is coming in a slow, another one is coming in a fast. Are you getting my point? Just to imagine, just for your convenience, I am explaining you. It is coming in a slow and this is coming in the fast. And if it collide each other means what happens? The colliding, after colliding, so think that it is coming fast and it comes to after colliding, it will move in a faster. So this will move in a faster, but it will move in a slow. but it means that it is having a slow motion. It is coming in a fast. After colliding each other, this slow particle will begins to move in a faster direction in opposite. Means after colliding, it will move in any other direction, but the speed of this gaseous particles will increases. After colliding, the speed of this faster one will becomes slower. Look here, it will move faster, whereas this one is moving slow. So it means that I am telling you here initially it is having larger speed, it is slower. After colliding, it is having larger, it is having slower. Together the total energy, how much it was having the speed, it will be remain same before the collision and after the collision. So this is our, we are calling that as a perfect elastic. In the perfect elastic, before and after the collision, the gases, the having the total energy of the gases remains same. If the total energy of the gaseous compound, the total energy of the gaseous compound before the collision and after the collision, they will remain same. This is called as perfect elastic. So here we have to remember that the gases are always perfect elastic. It means the total energy remains same before and after the collision. This is the fourth one. This is fifth one. The next one is different gases have different speed. So here different gases have different speed means in a container it may have the different gases. Hydrogen, oxygen, nitrogen. There are the different gases are present. So here different gases have different speed. Different gases have the different speed. If they are having different speed means it means for that reasons they are going to have, hence they are having a different kinetic energy. For that reason they are having a different kinetic energy. It means that the different gases have different speed and hence different kinetic energy. So it means that the gaseous compounds, hydrogen is having the lighter weight, therefore its movement is different. Oxygen is having the greater mass, therefore its movement is, means speed of that movement is different. Whereas sodium, chlorine or another gases like neon, helium, argon, so these are having the chlorine gas, it's having greater mass, the movement of that one is different. Why? Because their mass is different. So it means that different gases are having the different speed. For that reason, if they are having the different speed, the kinetic energy will be different. Why? Because the kinetic energy is nothing but what? It is the movement of the particle. If the speed is varies means, the speed is different means, it means kinetic energy is also a different. So here, explain the kinetic molecular theory of gases means you have to give the statements. So these statements are also called as assumption of gases or postulates of gases. So here I have written 6, at least 5 you have to remember. One is the gases are identical, small size. For that reason we are neglecting the actual volume. The gases do not have any force of attraction at ordinary temperature pressure, and gases are always have the constant and random motions. So they will be under always moving. And next one is the gases move in all possible directions in a straight line. They are going to move in a straight line. And next one is perfect elastic. That is, gases are having the perfect elastic. Before and after the collision, they are going to occupy the same energy. And last one is different gases are having the different speed. It means that they are going to have the different kinetic energy. So before all explaining this one, go through the points and try to understand, analyze by remembering the concept. So this is about the states of matter. In this, the very important one is kinetic molecular theory. It will be the fixed portion in your exams. It will be asked for 3 marks. You have to remember it. It's important. From this chapter, I am going to give you the assignment. Based on that, you can write it in an assignment notebook. Okay. So next one is we will begin with the new concept by on tomorrow. So we'll see what happens. And these two are important today's kinetic molecular energy and that previous one, Dalton's partial question. These two are important. And do practice. Don't wait for the exam purpose. Do well ready. So whenever we have asked you, you should be ready to explain that one. Okay. If you are having any doubts, you can ask me by calling. Confirm that. Okay. If you are having doubts, don't keep your doubts up to the exams. So we will meet on the tomorrow. Until have a nice day. Bye.